Hello folks, so in this video I'm going to solve for this problem. So solve problem 2894, divisible and non-divisible sums difference. It's a LeetCode problem. So let's get started. So let me get into this. I think this is some stuff that I was doing. Okay. I will probably stash this out. Send test data to API server. List pop I think we can give a name. Okay. Say blah, nothing, right? Anyways. Okay, so just gonna ensure that we have the latest code. Okay. So problems. Let's just make this problem 2894 divisible and non-divisible sums difference and okay. Let me open up this. Open this up and let me enable Golang extension and then open this up. So here we have Go. So let me start off by putting this in a package, maybe call it for now package, and oops, let's call it sums difference. Okay, and call it package, maybe pkg. Okay, and I'll just take this and write it here. Turn 0. Let me actually create the sums difference test.go, and I can actually get tests from this. Let me see, there's a test here. So let me get this and package. I put that here, and so here the input is actually n and m. Okay, so let's call it n and m. Output is an integer, so it's just an integer. So let's call it sums difference, maybe. or the result, right? And so we have the test cases here. Let's just give this input 5 and 6, and answer is 15, right? 5 and 6, result is 15, and then 10 3 result is 19. Okay, so 10 3 result is 19. So 5 1 5 1, so this would be minus 15, right? Because all the numbers are divisible. Usually when you look at not divisible numbers, it will be many, but when the m is pretty low, there can be many divisible numbers, and hence non-divisible numbers is very less. In this case, for example, 0 is a non-divisible number, so yeah. So 0 non-divisible numbers in this case. So now let's run these. So we have test, we call it difference of sums, and test difference of sums, and we'll actually take the input and give it. So it's a difference of sums, and test case input dot n, and then this one is test case input dot m, and then so input output and expected output. Okay, and input is basically test case dot input dot n, input n equal to m equal to n m dot m, and then output is equal to, and then test case output is equal to result, and you need to check the result basically. If the output and the result are not equal, then yep. So let's run the test and let's see how it goes. So we run the test and we should have failures. So it says there are different values over here. So n is equal to 5, m is equal to 1, output is 0, but expected output is minus 15, 19, okay. So the formula that I had for this was this. Let me tell that. So it's one moment. So it is based on the concept of sum of differences, sum of 1 to n numbers, sum of 1 to n, right? And you provide n over here, and the result is basically n into n plus 1 divided by 2, right? You can probably do this first so that this happens first, right? Sum of 1 to n, sum of all the numbers from 1 to n, right? So we can even have it as a capital N, and this assumes that n is positive. Okay, positive, that is n is greater than 0. Okay, so all the numbers, that is, let's just call it integers, right? So with this, the answer, this formula that we have is basically sum of 1 to n for n numbers minus 2 into, okay, actually, yeah, 2 into m into, we have to get this number x, which is equal to n by m, right? And as a sum of 1 to n x. So this is the answer that we want, right? X is uh, x is such that mx is less than or equal to n, and x is an integer, without any fractional part or decimal point. Let's just write that, or decimal point. Okay, so with that in place, let's see if the test works now. I think it works pretty well. So let me actually go ahead and put this here, and I will remove this, right? And I'll just run this. Let's see if it works. Yeah, it is accepted. So output is 19, expected 19, and output is 19. Cool. That is that. Let me submit this. And it is completed. Consistency is key. See you tomorrow. Okay, awesome. And yep, so view details. There are 737 test cases, and yep, so I have actually used very little memory. So very little memory. I've just used constant memory of 1. A lot of people have used more, I think. Interesting. 4 MB, this is 4.1 MB. Interesting. So yep. So regardless of what is the value of n, I've used the same, what do you say, size of thing. So yeah. This is a mathematical solution where more of mathematics formulas is used, and computation only for doing the math, right? And I can actually I think create a solution out of this also. I don't know how people do that. Let me see. Submissions. Okay, description. I think I have to exit this to actually be able to submit a solution. For example, if I click submissions and click this, here it will say write a solution somewhere. So I used Initially I thought of using plain and basic loop to loop through all the numbers from 1 to n and add up numbers which are divisible by m, and the numbers not which are not divisible by m. Later I decided to use math and math formulas. Sum of numbers 1 to n divisible by m minus, so this minus, so basically let me just say this, minus not divisible by m, was not divisible, result is equal to, so now I'll just do sum of numbers 1 to n. So this one I believe is basically sum of numbers of 1 to n minus sum of numbers. So basically, so if you see here now, you'll actually say result is this, right? And then you notice that you have two of them, right? So now you say this and say 2 into, right? So you have that, and then result is equal to sum of numbers of 1 to n is basically n into n plus 1, n into n plus 1 divided by 2, right? Minus, actually we have to say sum of numbers not divisible by n is basically, one moment, I feel like I made a mistake here. 1 moment. So all the numbers. So actually, it's sorry. We have to say the question is not divisible and divisible, right? And some numbers not divisible by m is r, and this divisible by. So it's basically not divisible minus divisible, and not divisible is basically all the numbers, sum of all the not divisible is basically sum of all the numbers minus sum of the divisible numbers, right? And then you basically put that, and so not divisible minus divisible, and then you say sum of divisible. So this is divisible, and this one is now sum of this, sum of divisible, and then you say sum of divisible line. Okay, so okay. Okay, so yep. So the not divisible is not there anymore, and it's just divisible. Oops, what did I do? Oopsie doopsie, did I do something crazy? Damn it. Generated from chosen submission. Okay, damn it. Okay, I think I might have to write that again. So, so I'm just going to say initially thought of looping through all the numbers from 1 to n and finding the sum of all the numbers. So if I just basically do a check, if I do escape, it just goes off, I think. Anyways, so just gonna cancel it for now. I think I'll just do that here before I put it there. Because if I do an escape, it just goes off. I'll put this up, and finally I'll just copy paste there, right? Anyway, so that's all I had for this video. Solving this problem. I'll see you in the next one. Bye bye.